Okay, let's get started. Hello and welcome to how Vonage reduces troubleshooting time and deploys features 2 times faster with Epsagon. My name is Carmen Puccio. I'm a Principal Solutions Architect here at AWS, and I'll be a host and the moderator for today's presentation. When you join today's webinar, you selected to join by either phone call or your computer audio. If for any reason you would like to change your audio selection, you can do so by accessing your audio pane in the control panel. From this control panel, you also have the opportunity to submit questions to today's presenters by typing in your questions into the questions panel. We will collect the questions and address as many as we can during the Q&A session at the end of today's presentation. Also, at the end of today's event is a brief survey. Please stay connected until the end of the broadcast and submit your feedback, as your opinions do count. And lastly, the PowerPoint presentation will be available through SlideShare along with the recording of the webinar on YouTube. You'll receive an email that will be sent 2 to 3 days after the conclusion of this event, so keep an eye out for that follow-up email sent to the address you provided. So with that said, let's get started. I just want to kick off with a quick agenda. So the first thing we're going to do is we're going to do a flyby around modernization and containers and serverless on AWS and just how we see them fitting into the overall topic of modernization. And then Rand from Epsagon is going to talk about observability and modern applications. And then we have the customer story of Vonage and essentially how they drove their modernization journey using Epsagon. And then we're going to get into the Q&A and we'll talk about any next steps and follow-up items. So with that said, I just want to introduce today's speaker. Again, it's my pleasure to present to you today. My name's Carmen Puccio. I'm joined with Ron Ribbenzoft, who is the co-founder and CTO of Epsagon, and Ilya Rabinov, who's the R&D manager at Vonage.
Thank you very much, Carmen. It's a pleasure to host it on your webinar.
Yeah, thank you. Thank you for joining.
Sure.
All right, cool. Cool. So let's just jump right into this, and we can get to the Epsagon and customer story. So modern application development. If you joined any AWS webinars in the last year or so, you'll see this is a very hot topic. I've presented on it many times, and I like to just like set the stage with this and talk about the new normal. And when I say the new normal, I talk about application leaders understanding essentially a new digital DNA and how they can instill this into their culture and their processes and the various different technologies to transform their organization into a top performing organization. And really the need here is rapid innovation. And this is because more and more companies are going increasingly global and products are completely digital. So cloud, mobile, big data, social technologies, they've impacted application development. And essentially what they're seeing is a digital disruption that's forcing change at a tremendous pace. And if you've seen any AWS slides recently, this is another very popular one. I call this the innovation flywheel. Think of this as essentially the faster that you can get feedback, the faster that you can drive growth into your organization. And you're looking to essentially, take that feedback and use it to react quickly to your customers. You can use it to also do things like reduce costs as you experiment on new ideas. And in reality, what you're trying to do here is get your ideas to market as quickly as possible. And when we talk about the innovation flywheel and the technologies involved, we talk about a variety of topics, but today we're going to talk about containers and we're going to talk about serverless as essentially the key technologies that you want to think about as you're driving business forward. Containers have been around for a long time now, and when we talk about customers accelerating application delivery and also reducing costs, containers is a very common approach. And the container story is really compelling because one of the big benefits is essentially becoming more effective and agile in your practices. And containers provide an option to develop your applications very, very quickly for the development and operation teams who are under pressure to adapt to growing business needs. And businesses really, they know that getting software products and services to market faster translates into a gain market share. And using containers can help enterprises modernize their legacy applications to create net new cloud native applications that are both scalable and agile. So container frameworks such as Docker provide that standard way of packaging applications, the code, the runtime, the libraries, and run them across the entire software development lifecycle, regardless of your environment. And when we talk about the benefits of containers, it shouldn't be a new topic to you, so I'm not going to dive into all of these. We have a ton of material about this. I want to talk about some of the high-level things here, and particularly I want to talk about microservices. And containers provide process isolation that make it very, very easy to break apart and run applications as independent components. And when you think of microservices, you're thinking independent components. And modern applications that are shifting to cloud native and microservice architectures are using containers and leveraging containers because it's a perfect way to encapsulate the various different pieces of your application into portable units. And when we talk about, another benefit too, I want to talk about monitoring because it plays very nicely into the Epsagon story, is containers provide process isolation that lets you granularly do things like setting CPU and memory utilization for better use of compute resources. And with that said, it's very important to think about the application level monitoring and how you're going to ensure the overall health of your application as your containers spin up and down in a dynamic environment. And when you think about microservices and you think about multiple application components talking to each other, being able to trace that out in a very clear and concise manner is very critical to your organization. And we'll talk about that as well in today's webinar. So I'm not going to go super deep into this. Again, we have a ton of material around AWS Container Services. What I want to say is our customers do love AWS Container Services because it not only provides that broadest set of capabilities for them to manage their containerized applications, but it's also the easiest place for them to run their containers. And when it comes to running containers on AWS, you have multiple options. And the thing to think about here is our services are deeply integrated with the various different components of the AWS cloud. So you're getting benefits like IAM security and VPC networking and load balancing. And essentially it's enabling you and your teams to essentially build DevOps processes using things like our developer tools. And we're super excited about the ecosystem of services that we now have enabling AWS to be the best place to run containers securely and at scale for production workloads. So it's not all containers, it's also serverless. A lot of times when I talk to customers, it's a combination of the two. So when you're thinking about modern application development, you're thinking about making that shift to cloud native, serverless is 100% in play. And we see customers adopting serverless technologies at a tremendous pace. And the way to think about it is serverless is the native architecture of the cloud that enables you to shift more of that operational responsibility to AWS. So increasing your agility and increasing your innovation. And serverless allows you to build and run applications essentially without thinking about servers. And it eliminates the infrastructure tasks that you're used to seeing, such as things like cluster provisioning or worrying about patching or worrying about the OS maintenance or even worrying about overall capacity provisioning. You're building your application or you're thinking about building for nearly any type of app or backend service and really thinking about what's required to run and scale your application, that's handled for you. So to double down on the benefits of serverless, it's important to realize the removal of the undifferentiated heavy lifting that is server operations. And this is really important in terms of distinction for our customers because it allows customers to focus again on building the application rather than thinking about the management and scaling of the underlying infrastructure to support that application. And this means thinking about infrastructure or not thinking about infrastructure or scaling. It means you really are only paying for what we describe as value. And it really means that you're thinking about the availability and security, but again, that's built in for you as well. So the key tenets here are no infrastructure to manage or provision, meaning no servers to provision, operate, or patch. It automatically scales by the unit of consumption, meaning think of scaling by work unit or consumption rather than individual server unit. And think about pay for billing model. And again, this is something where we talk about as well, where you think about the built-in availability and fault tolerance. That's a tremendous value. So there's really no need to architect for availability because it's built into the service. And when customers think about serverless, a lot of times people think about Lambda, right? And serverless is much, much more than Lambda. For example, AWS Fargate, we classify that as a serverless service. So while it is something that allows you to run your containers, we classify that as a serverless service because we're doing the underlying heavy lifting for you and you're focusing on your application. So thinking about Lambda or Fargate, it offers many advantages for our customers. And really when it all boils down, We want to talk about the bigger benefits, right? What can you actually put in place that make these applications truly valuable to you? And this is where you start to see all of the supplemental services that you see below being kind of built around that underlying application, again, whether it be running in Lambda or running in Fargate. And once you start putting all of these applications together, or all these services together inside your application, this is really where you start to see tremendous gain. And lastly, I want to just get into some of the foundational components that you need to think about. So we've talked about some of the services that you can take advantage of, but it's really making sure that you have these processes, because without these processes, it's very hard to achieve what we call modern app development. I don't want to go super deep into monolithic versus microservices. I think everyone here probably knows, the high level, pros and cons here. The thing that I want to talk about is monolithic architectures. You want to try and eliminate the friction that comes with maintaining a monolithic throughout a software development lifecycle. So thinking about a small change, it's going to take a very, very long time to go through a release process, and it doesn't lend itself to that quicker to market concept that I was talking about earlier in that innovation flywheel. And if you think about it, it's 2020, and it's unacceptable considering the technology landscape that's available today. And I personally consider that long life cycle a legacy development culture, like a leftover artifact of it. And you want to think about how microservices address that problem. Meaning the benefit here is because each piece is separately deployed, they can interact with each other, and you can achieve a much, much broader use case. And this is because they're organized around capability and can be scaled independently. Thinking about the fact that each microservice talks to each other, and it's usually published via an API, and those APIs also have something that's published. It allows the teams to essentially independently architect and develop and deploy and maintain their own microservice. We talk about pizza teams a lot, where essentially the pizza team is the owner of that application from development through production. And it's something that we feel very strongly about. And when we talk about microservices, you want to think about how you can achieve that overall, I own this application, all the way through the software delivery of the application, all the way through to production. And how can I get complete visibility into that application through the various stages so I can fine tune it and drive that innovation flywheel that we were talking about before. And again, you'll see serverless and containers quite a bit inside of that microservices use case. You can't do any sort of modern application without CI/CD. Again, this should not necessarily be a new topic. You can see these numbers here from the DevOps 2019 report. The point that I want to just call out here is by incorporating automation and that cultural component, you need to learn how to integrate frequently, meaning your customers, you want them to be able to find the ability to find bugs quicker, address bugs quicker, improve software quality, and you want to reduce the time that it takes to validate and release net new software updates for your platform or for your applications. Again, driving that flywheel as fast as possible. And security is also a key concept, and you want to think security in the overall topic of software delivery, right? And it's not necessarily at the tail end. We talk about shift left now, and it's paramount that any organization, you think about essentially all of the various different attack areas that a microservices-based architecture could be prone to, and how you would protect and audit them. So a very good example is, you're thinking about security scanning, and this is how you're going to achieve vulnerability and security within either your container or your Lambda functions. And perhaps your application is dependent on like an external package, or you're inheriting a base container image, and then maybe you're rolling your own image. How do you know that the components that are in there that you're dependent on aren't vulnerable? So think about runtime monitoring and what functions and containers are already running in your production environment. And it's really critical that you understand, if a security release comes out for a particular package, how are you going to audit it? Again, these are the things that we talk about. Security is everyone's job, and developers need to understand that it's not necessarily handing the application off to another team. It's really everyone's job. Everyone has a stake in security, and everyone needs to essentially have a factor or be a part of the decision that talks about how the applications are built, tested, and deployed through that software delivery lifecycle. The last slide that I want to talk about before I hand it over to Ron is the monitoring aspect, and I know that's why you're here today. It's a very important, oh, I went one too fast. it's a very important concept. Again, you have all of these microservices in your environment. How do you do things like maintaining, essentially the part around reliability and availability and performance of your modern application? And how are you thinking about collecting that various different monitoring data from all the parts of your application so you can easily debug in case a failure occurs somewhere inside of that application architecture? And before you start monitoring the application, make sure you have things in place or a monitoring plan that answers questions like, what are the goals that I'm trying to achieve? And what resources am I trying to monitor? And how often am I going to monitor these resources? And what tools am I going to use? And who's going to perform them? And who should get notified if something goes wrong? And then lastly, as part of it, the most important one, if you're thinking microservices, think about distributed tracing. I know Ron can talk about this, but many cases, a set of microservices work together to handle that request. And in a complex system where you have tens to maybe hundreds of microservices, if an error occurs in one of them in that call chain, how are you going to debug that properly? And how can you expose that into a central system to find all of the relevant log messages or to find that failure point? Something super critical to think about. So with that said, before we hand it over to Ron, there is a poll. I just want to bring this up really quick. So just really quick, if you just want to throw your answer back in here, what solution do you have in place today? Do you do something in-house in terms of monitoring? Do you use something like AWS X-Ray? Do you have a third-party? Do you have a third-party tool inside your organization? Or I've seen it before. Do you have logs everywhere and you're trying to assimilate essentially what's going on inside your environment? So go ahead and throw your answer there if you could, and I'll hand it over to Ron.
Yeah. In the meantime, by the way, Carmen, I would love to ask a quick question. What would be your recommendation for people that already doing a monolithic and now they're on the path to break down their monolithic application into microservices? What would be your go-to or your recommendation for such organizations?
Yeah, absolutely. Yeah. So the first thing, again, it goes back to that planning and understanding and start slowly, right? A lot of times when we talk about application migration, we talk about the discovery portion. You really need to understand what's talking to what. You need to think about right sizing that application as the move to the cloud. You need to think about what it's doing, because as you lay that blueprint down into AWS, you want to make sure that you've accounted for everything, essentially cross all the T's and dot all the I's, if you will. Thinking about security groups and NACLs and permissions, you don't want to necessarily move it without making sure that all of your homework's done, because the last thing you want to do is cut over and then impact your users. But once you've moved it, what I've seen a lot of customers do is move things over to essentially what I would call a fat container. And when you call it, it's not necessarily a bad term, it's putting that application, assuming it's capable of doing so, inside of a container and then wrapping it with a CI/CD pipeline or a software delivery pipeline that allows the development teams to make slow iterative changes over time to that application to slowly deconstruct it. And then once you've gone down that route, we see them start to take advantage of more cloud native patterns, like things like AWS App Mesh for service-to-service communication. They're leveraging some of the core foundational elements of sending logs from those applications into a centralized logging system. It's really about, again, introducing those changes to that monolithic application after you've planned for how can I move this, and then how can I subsequently make changes to it in very small, meaningful chunks without impacting the overall performance or the customer experience.
Yeah, I completely agree. And I think that's actually a great segue when you spoke about moving from monitoring to observability. And in the following part, I'm going to drill into observability and what it actually means, because some people really, losing their hands when they start to implement observability, especially in modern applications. So what we'll cover is, monitoring 101, the basics of monitoring and how to get started, and some of the best practices, both in observability and in all of the pillars of observability that we will learn. And ultimately, we're going to speak about distributed tracing, which, as you, Carmen, mentioned, it's becoming more and more crucial part as part of the observability in modern applications. So let's get started. First thing that I love to ask people is, what should we monitor? Like, what are the vital signs of our applications that using them, we know that everything is working properly? And I think, there are 4 golden signals that are defined, and they're defined pretty well. And the 4 ones are, first one, latency, which makes it pretty obvious, because latency tells you what's your customer experience in your product, in your application, or whatever that you're building. Then comes the traffic, which helps you understand, am I handling the similar traffic? Am I having a spike or down? So it helps you understand what's going on inside your application again. Errors are pretty straightforward. I mean, we want to zero them as much as possible, but it's super interesting to know whether we got some errors, specific kind of errors, what kind of them, and which users are being impacted. And ultimately, the fourth one is something that many people are forgetting about, is saturation, or in other words, how full is our service? Because we can look at the rest of the three and everything will look fine. But all of a sudden, our service is getting 100% full. We can't process any more requests or any more new data. So this one is also important to understand that we're in a good ratio to handle more traffic. Once we're doing this kind of monitoring, we need to actually start to collect the information itself. So in the traditional kind agent-based approach for monitoring, so if we had this kind of service, whether it's a monolithic or a microservice, that we had some API and interaction with some database, we usually used to place an agent on top of that, either a container or a host or any kind of a variable for that. And it would collect host data, starting from CPU, memory, network, disk, and it could go all the way to processes and ports and things like that. The only inherent problem with using this kind of agent just for monitoring, when we're speaking about the observability, is that it's just metrics. I mean, if you need to dig into a specific problem, you're just getting the metrics themselves. Which leads me to the fact that when there is a problem and we need to troubleshoot, we need some debug data. And metrics, there are just one step of the symptom, but we need to understand exactly what went wrong. And here exactly comes the logging part. Where in logs, again, in the agent-based kind of solution, you would put another agent next to the monitoring agent. Sometimes they are combined, sometimes they are different. And in this case, you would dump the logs either locally in the more traditional and old kind of applications, or in the more modern one, you ship all the logs to some remote centralized logging solution. The inherent problem that comes with logging is that only the thing that you're logging, i.e. Only the things that the engineering are deciding to log out and the way that they decide to log out, these are the things that will be logged, nothing else except for that. And with such dynamic environments, like if you're using Fargate and Lambda and some other services, you won't be able necessarily to go back to the same invocation or the same call at the specific host, because the host is not accessible anymore. It's not part of your responsibility. So having both monitoring and logging allows us to gain some understanding of the application. And when we're moving towards more modern kind of approach of applications building on the cloud, so we're looking at two main parameters. One of them is where the kind of the infrastructure is running, and the second one is the composition of the application. So starting with the most traditional application, host-based monolithic application, used to be relatively simple to understand and troubleshoot what's going on. And then, came the all part of containerization and distributed applications, which broken down our monolithic application into several microservices, which introduced some complexity, but it was still manageable to some extent. And then two factors really changed dramatically. One of them is the host became more and more abstracted, especially if you're thinking about AWS. You got in the serverless spectrum things for compute like Fargate and Lambda, and you got managed queues, managed databases, managed storages, managed web servers. You got so many resources that are already managed for you, where you don't even have the host for them. You can't access the host of, for example, your S3 bucket. And also the applications became one step more complex. If you would have 5 or 10 microservices, all of a sudden you have hundreds of pieces going on in production, and you need to understand the intercommunication. And this is, just a very small example of an application running on such scenario. In this kind of scenario, we're introducing different challenges, both for the engineering and the DevOps. First one, and the most significant one, is the troubleshooting. Understanding a scenario where a user request moves from different services to different services in your architecture. Troubleshooting such scenarios can be a nightmare. Understanding what was the path and which user got affected and where exactly and where are the logs and how do I correlate between them becomes a big pain. So this is the first one. Secondly is monitoring. Being able to visualize such complex scenario with so dynamic kind of approach, you need a different kind of tool that allows you to understand it and detect whether you got bottlenecks or any performance issues. And also in terms of development, if you're doing troubleshooting and monitoring correctly in production, it helps you iterate faster on your development lifecycle and ultimately ship features faster, which is super important. Actually, I missed one thing, so I would love to ask you, everyone over here, just a quick poll out there. What kind of services are you using today? So the poll should be there. Sorry, where are you on the scale of this graph? Are you still running on premises, monolithic application? Are you already in the cloud? Are you running microservices or serverless? It's interesting to know among all of you to have a better understanding, because we even see some kind of hybrid architectures, but it's interesting to see, how further are you down the scale. And in the meantime, I think I would love to ask Ilya next to me. You started at a different point, but today, where would you put yourself in this kind of spectrum?
So definitely between microservices and the cloud and serverless, somewhere right in the middle.
Yeah, I think it definitely makes sense, especially for a company that building new products, shipping new features. It makes sense to go as further as possible.
Definitely.
Thank you for that, and we're going back to the slides. So after we understand what are the new challenges that we're facing today, it's interesting to know that when we're speaking about observability, it's not just about metrics or not just about logging, it's the composition of all of them together. So metrics, we already know, these are the CPU and memory and any kind of metrical data that we can put into a data set and aggregate it into a meaningful insights. Then comes the logging that helps us to understand, helps the engineers to understand what's exactly the problem that we're facing or any data that we're facing. And tracing, that becomes the most crucial part, usually differentiated into a different solution. Usually you find solutions for each and every pillar in observability, but tracing helps us to understand a request as it propagates through the system and gives us some more enriched data to understand exactly what went wrong. And with that, just before diving into distributed tracing, I would love to cover some of the best practices both in monitoring and in logging. So for monitoring, very straightforward. Try to aggregate as much as possible all of your metrics into a single solution. This solution can be CloudWatch or any other solution that you get. All of the kind of a single pane dashboard that you can get all of the metrics out there. And super important on top of that, to build an alerting system that will alert you only when it's critical, or in other words, set the threshold only when you're having a real problem, because otherwise if you're waking up at 4 a.m. in the morning, it better be worth it. It better be, something important. Use custom business metrics. Ship your own metrics as part of your application, because that's what you're tracking. You're making sure that your application is working properly, and also make sure to monitor the application level metrics. Things like, what's the average duration of a call coming into your web server, so you'll understand what's the latency that the customer is having, or number of 400 or 500 errors. These are super important, because honestly, this tells what your application is experiencing and ultimately what your customer is experiencing. In terms of logging, so first and foremost, ship your logs in a structured way. Don't just put raw text into your logging, put them inside a JSON or any kind of structure that fits your needs, that will be enriched with some more metadata. For example, which service is sending this log, or what stage am I? So then you'll be able to filter things like, show me all the logs that contain this message, but there are prod environment and came from the payment service because I'm troubleshooting something over there. Also try to automate as much as possible the process of logging. Try to make everything automated and part of your framework, so the engineers wouldn't need to manually put every line of log into what they're doing. And centralize the logs, same as monitoring. Try to put all of the logs into the same kind of solution that will aggregate everything all together. Now even if we're doing everything over here, we're still missing something. And the first one is, how do we correlate between metrics and logs? We're having a metrics of, our RDS database is having slow performance. And how do we get to the right logs to understand what really impacted or which users are impacted? Secondly, how do we know like what's going on each and every request as it moves between different services in my application? So being able to trace down this kind of scenarios is exactly where distributed tracing fits. And distributed tracing, in other words, if you can see on the right side, just tells me a story. It tells me a story how a request moving from one service to another, for example, from the client to the load balancer to different services in my application. And in order to do distributed tracing, we have two parts: generating traces and ingest them and visualize them. So let's start with the first one of generating the traces. For generating traces, it's pretty straightforward to understand it, but much more complex to implement it. So first thing that we need to do is to instrument calls. In other words, we need to make that every time that we're calling the AWS SDK, for example, to do any operation against S3, DynamoDB, or any service that we're using, we want to be able to get the request and the response in an automated way. So when we're doing something in the code, we don't need to manually annotate every operation that we're making. Next, we need to create a span that, in other words, tells me about an operation that took part from time to time, like start time and duration. To that span, I'm going to add some context. For example, if I'm making a call to a DynamoDB, I'm interested to know which operation have I made, and what is the table name that I'm doing, and what is the key. Some information that will give me some more context into that. And ultimately, I need to inject and extract IDs. If I'm moving between different services, I need to be able to inject a correlation ID that the other part will be able to extract and understand that is part of a same story. So then we'll be able to visualize that. On the right-hand side, by the way, it's a short example from Open Tracing, a popular CNCF standard that tells you or acts as a framework to tell you how do you do trace in your own code. And this is just an example for an HTTP kind of a request. After we're generating traces, we need to ingest them and do something with it, or use the tracing that we're doing. So we need to first of all make sure that we're having a system that can ingest our load, whether it's millions or billions of traces a day. We need to index the context and the tags to be able to search, aggregate, or pinpoint things that we're having. We need to be able to visualize our traces, the stories that we're having, either in a graph or a timeline that will tell us where we spend our time, set alerts, and so many more things. But this is just very the short list of using tracing in production. Just before handing over, I would love to talk about some of the best practices in terms of tracing. So first and foremost, tag your traces with additional information. This additional information can be crucial. Things like identifiers, for example. If you're tagging your trace with a user ID or a customer ID, then once this user ID or customer ID comes to your help desk and says that he couldn't do something or something failed for him, you can easily filter that down using the tracing because it's already indexed. Next can be a flow control to tell us what we're doing inside our code, or how many events of type upload versus download we're having in our system, and ultimately also business metrics. This is taking tracing and tagging to a next level of helping us understand exactly what's going on in our system and plot it into charts. After we're tagging traces, we can even take it one step further. Let's capture all of the information that we're seeing. So instead of manually log what we're getting on every request or what we're doing every line of code, let's capture all of the information, for example, from HTTP headers or body. Then we'll have all of the IDs that are coming in and out. Or let's display the key or the query of the SQL or NoSQL database that will help me understand exactly what went in this scenario. Or even response payloads from third-party APIs that we're using, all can be super helpful when we're troubleshooting applications. And lastly, tracing can act as a glue. When we're doing a good kind of tracing, it helps us to get directly to the logs that we're having, or even correlate between the trace and the environment to understand, oh, this trace is a part of a Lambda function and we understand what's going on inside that Lambda, or this is a part of a Fargate service and we know exactly what went at the specific time where the trace ran. Some of the best practices for observability: try to automate as much as possible the process. This is super important. Make sure that the solution that you're picking supports any kind of environment that you're using, varying from serverless to containerized, Lambda, Fargate, Kubernetes, AppSync, and so on. Make sure that this kind of solution connects every distributed trace that you're having in your system, that it allows you to search and analyze data across any call that you're having and helps you to quickly troubleshoot problems. This is really boils down to this is the main part that allows engineers to iterate and move faster. Just few remarks before Ilya kicks in. Some of the great benefits of using such a solution, and especially Epsagon, for example, reduction in troubleshooting time, super simple setup, and reduction in error rates, which is super important for, I think, every organization and every company out there. And just as a summary, we understand that modern application requires more than just simple plain monitoring, and the distributed tracing turned to be a crucial part in such environments. And I think as a quick tip, and we'll learn a lot from Ilya's journey, that you shouldn't focus on implementing in-house solutions, because that just would consume most of your time to something that is not your core business to do. So I think with that, I would love to hand it over to Ilya over here.
Thank you, Ron. Thank you for this great introduction. And so as just Ron mentioned, my name is Ilya, and I'm R&D manager for Vonage in Tel Aviv. I'm very excited to be here since Ron is a very close friend of mine, so I'm twice excited than usual. And I would also like to thank AWS and Epsagon for having us here on this webinar so we could tell our story about our wonderful journey for joining the serverless community. So before I start, I would like to give you a brief about Vonage. Vonage is a cloud communication provider that operates in 3 main categories. The communication APIs, which allow our users to have voice, video, messaging, or any other communication API that you can imagine at any scale. The other one is unified communications, where we allow, whether you're a small pizzeria or an enterprise business, we will get all you need in communications in the cloud in one place. The third one is contact centers, where we will customize all your needs and integrate it with your favorite CRM, and then run it in the cloud for you. And probably the most important value proposition from Vonage is the fact that we allow, sorry for that, it jumped. Yeah, and the most important is that we control the stack for all 3 components, and we're not integrating any third parties for that. So all the technology underneath is proprietary for Vonage, and this is how we help our customers to achieve the best possible solution for them. Okay, and specifically, I would like to focus on unified communication because the R&D center in Tel Aviv is mainly focused around this product. So Vonage Business Communication, or VBC as we abbreviate it, is a platform that allows you to have all your calls, SMSs, video chats in just one application, whether it's mobile or web. So I would like to start with saying that writing code is hard. It's a very hard job, and if you want to do it right the first time, there is a lot of unknowns, bugs, stakeholders, and the list goes on and on. So as developers have to focus on delivering business value for our customers. So how can we achieve this? And I would like to use an analogy for that. Let's imagine that we are a faucet company. So we would really like to focus on building faucets that would delight our customers, right? We don't really want to handle with the plumbing underneath, because sometimes plumbing might leak, might be messy, dirty to deal with. So we actually want to focus on creating beautiful faucets. And our customers don't really care about the plumbing underneath as long as the faucet is beautiful. So just as Carmen was saying, we would like to focus on flying this innovation wheel and just delight our customers. And that's actually why we decided to use serverless technologies whenever it's applicable and possible. It really allows us to focus on what matters the most. We don't have to worry about over or under provisioning. We only pay exactly for what we use. AWS takes care of the infrastructure security for us and the patching for it. And it makes us a lot easier to support spiky workloads since you get all the resources that you need on demand. And I would just want to give us a few seconds for a quick poll.
By the way, yeah, so the poll currently is to understand what kind of services are you using in terms of compute. So we got Lambda, Fargate, ECS, EC2, and EKS, and actually really relate to something that you mentioned. You know, writing code is not the desired goal. This is what we're doing to get to the desired goal. And I think somebody said it really nice on Twitter. He said that code is a liability. It's not an asset. I mean, the more code that you're building, it's not like, you know, your company becomes better. It's the opposite. The more code that you're building, the more code that you're liable and need to be worried about. So the less code that you're building really puts a great kind of focus to the organization to move fast and focus on what you're building rather than, you know, building it from scratch.
Exactly, and the other day I was actually listening to a lecture of AWS CTO Werner Vogels, where he was saying the future of developing code is just writing business logic. Yep. You don't need to mind about all the infrastructure underneath.
Right.
And I really relate to that. So at Vonage, we use almost every serverless offering AWS has. And I would like to highlight some of them and to give an example for one or two of them. So we, of course, use AWS Lambda and step functions. We actually, one of our products, which is called Visual Voicemail, is where you get a voicemail to your mobile number or your phone number. We basically speech to text the entire conversation, and only if there is speech and no just static noise that somebody left you by mistake, will send you a notification or an email with the transcribed call, and then you will be able to decide whether you want to call back to this number or just listen to original message and stuff like that. So it makes your life easier. So we use step function for that, and we'll see the example around the step function for this exact scenario. We also like to use Fargate for our containerized workloads whenever we can. We'll leverage Aurora and DynamoDB in the serverless flavor for our Q&A and dev environments. This way you can actually achieve some savings because you only use those when you're actually testing or developing, instead of just having some machines running all day long or trying to figure out if you can shut them down at 5 p.m. when everybody goes home, and when exactly do you need to turn them back up, stuff like that. Just use serverless and you pay for whatever you need.
Yeah, so for example, your DynamoDB in production cost what it costs, but in dev and QA it's probably cost almost nothing.
Yeah, exactly. And it's funny amounts in dev and QA.
Mm-hmm.
And of course, we use almost every other serverless offering AWS has to give, like API gateways, SNS, SQS, whenever it's applicable. Okay, so we need to skip that. And now I would like to discuss, I would like to show you one of our usage patterns during a regular week. In the top graph, you can see an example of our workloads in one of the US regions. Since our customers are business customers, they usually work for 5 days a week, and as you can see, the graphs peak during business hours in the US, mostly 8 to 5, and once our customers leave the office, they stop calling, and therefore we can see that the traffic drops drastically. By the way, those graphs represent billions of invocations, of function invocations on a monthly basis. So during peaks, those are hundreds of millions of invocations. And if we take a closer look, the upper graph would scream at you saying auto-scaling. You have to use auto-scaling to solve this, right? But actually, if we would look at the let's say, old paradigms of development, you would probably have to over provision for max capacity, and then you will want to think about high availability, and then you will have to capacity plan twice the amount of servers just to handle a crash and bailing out of one region to the other. And this would cost you a fortune. So serverless really helps us, and in a second I will explain why exactly serverless. So in the graph beneath, we can see a zoom in for a peak hour of one of those days, and what we can see that it's very spiky. It's like plus minus 15% deltas that occur within seconds and minutes. And it's very hard to predict those loads because they actually depend on how much our customers making calls. And if we weren't using solutions like Lambda in order to solve this, then we would definitely be hitting some thresholds with over provisioning or under provisioning, and therefore not providing service to our customers. So after starting our serverless journey, serverless introduced a lot of benefits, as I described before, but it also introduced us with some challenges. When developing serverless application, even the simplest application has a very complicated architecture diagram. In general, the code for functions tend to be very simple, and those functions only do one task at a time. So this leads to a lot of functions per application. In addition, we use a lot of managed services for all kinds of tasks. And when you combine those two things, the architecture tends to get complicated. The complexity of an application moves from the code to the architectural level. And it's very, very hard to debug those applications or even to test your serverless workloads, since you will have to mock most of the components in the system or set up special environments to run the application on your local machines during your development phases, and it introduces a lot of complexity. And since the system is so complex, it will be much harder for your engineers to find the root cause of all the production incidents, since it will take them longer to see the big picture without the right tools, without the right monitoring in place, which will help you with your tracing, just as Ron mentioned before. Of course, there are some hidden costs that comes when using serverless technologies. For example, the only way to access your application logs would be via CloudWatch or any other centralized login solution you will select. But for instance, CloudWatch, they have a very sensible pricing, but when running workloads in a large scale, you'll probably find yourself paying more for logs than the compute power. And it's also hard to ensure predictable startup times for functions that are rarely used. You'll have to introduce some specific logic to remedy those, and it will be even harder if you decide using programming languages like Java or C#, which comes along with the JVM, and they are heavier, therefore more pricey and slower to spin up. The other thing is edge cases. When you have workloads of hundreds of millions or even billions of invocations, it's really hard to find that 0.01 of your invocations are timing out, or they run out of memory, or they just run 10 times than your average or something like that. So it's very hard to find those without the applicable tools in place. And now I would like to show you the step function for the visual voicemail feature that I was talking earlier. So as you can see, it has 25 stages. It's very complicated to debug it, and every time you have to find an issue somewhere, you just need to start looking for this function and this function and this function. but when it works perfectly and serves your customers as best as it can.
Yes. So each function is like super simple, doing a very simple task, but combining all together and understanding the intercommunication between one another becomes a pain when something green here turns to red.
Exactly. And luckily for us, both AWS and Epsagon are constantly changing and improving in order to make those stuff easier for us. And so now why we decided to go with Epsagon, and I would like to let Ron showcase some of the bullets with the actual screenshots from the application.
Yeah. So, in general, having everything under the same dashboard, being able to drill into the payload of every call and understand what's going on, this is really the scenario. And, some of the examples that we can share from the Vonage experience. So starting first with Vonage, as you see, got almost 2,000 functions in their environments. This is something that is definitely hard to keep track on, especially when you're having several stages, several AWS accounts, an application that deployed to several regions. This is hard to keep track on. And as Ili mentioned, this is really high scale. Having hundreds of millions of requests every week, this is something that you can't really follow on. And especially when you're having things like timeouts or running out of memory, this becomes very hard. So how does this kind of view help you stay on top of the problems?
Yeah, so definitely once you have an aggregated dashboard that shows you all the errors a specific function has, all the timeouts, all the times it runs out of memory, just in one place, instead of trying to figure out of 100 million invocation of a specific function whether or not there were errors or timeouts, it's very, very hard. So this aggregated dashboards makes our life very easy.
Mm-hmm. And same applies for ECS services like Fargate or plain EC2 launch type. You can in overall see exactly what's going on in each cluster, in each service, being able again to have everything under the same dashboard and ultimately visualize an architecture. So this is a small subset of the application, and you can see how complex it gets. I don't know, tell me what we were seeing.
This is my headache every morning. No, but this is actually one of our architecture for one of the APIs that we serve our customers with. And when you see something so visual, it makes it really easy for new engineers or someone that doesn't understand very well the architecture to see the bigger picture within seconds instead of trying to figure out what's going on in a list of 30 lambdas.
Mm-hmm. Especially compared to logs. And if I'm drilling down, being able to see every call inside the stack and know exactly where it's going to and what's the payload and what are the keys and which user did it, and even switch from a graph view to a timeline view to understand performance issues. This is, I think, if you'll correct me, this is the thing that help you move fast, to understand fast what's going on.
Exactly. When you try to figure out an error that you have in production, you don't have the luxury to stop everything and try to figure out, view the logs. You need something very visual, very immediate that you can access to see all those traces and what exactly going on.
Yeah.
So basically, thank you, Ron. And after installing Epsagon, we saw value within days. We decreased the mean time to resolution for production errors in 25% during the first calendar year after starting using Epsagon. The distributed tracing enabled us to decrease debugging complexity of our applications. It's much easier to do it when everything is laid out visually in front of you, just as you saw in the previous examples. Mm-hmm. For new engineers, it's very useful to see the architecture map or some of the workloads to comprehend the system better and make wiser decisions based on that. And Epsagon tracking for specific workload costs has enabled us to save tens of percents the cost of some of our functions. So it's just a great product.
Amazing. That's super great to hear that. And especially for everyone that here now, we would love to see you getting into Epsagon and visualize your kind of architecture. As you already know, Epsagon supports all of the modern kind of applications, ones that are running on containerized environments like ECS, Kubernetes, EKS, Fargate, Lambda, and so on. So we would love to see you coming in. And thank you very much for that. I think it's time for a Q&A. So I'd love to see if you have anything from the crowd, Carmen.
Yeah, awesome. So thank you very much, Ron and Ilya. It's a fantastic talk. As Ron said, we're going to transition to the live Q&A, and just a reminder to folks who may have joined late, you can submit any of your questions written, through the panel. And in the event that we can't get to your questions today, we will follow up with everyone individually via email. So with that said, we have about 4 minutes. So we should be able to get a couple in. The first one, it looks like, Ran, we talked quite a bit about just, overall monitoring. And I even touched on the concept of figuring out almost a monitoring checklist. In your experience, what are people looking for? You may call it a checklist in a monitoring or observability solution.
Yeah, so I think when organizations are coming into the path of enlightenment or path of observability, usually it's being driven either by engineers or by DevOps. It really depends on the culture of the company, but they're looking for first a solution that fits their kind of environment. Just as Ilya did, he knew exactly what he's having, what his tech stack looks like, and what it's going to be in the future, and what exactly he needs. So coming with a criteria to understand what will be a benefit for observability, it's the first thing. Secondly, understand, organizational wise, are you going for the do-it-yourself kind of solution or the managed solution? Obviously, there are trade-offs for here and there, but my quick recommendation would be try to stick with a managed one. And ultimately, the last thing that I can really recommend for, in terms of a checklist, once you're getting your hands dirty, is to try to communicate the value that the business is getting using such a solution, because sometimes it might be seen for the senior level as another engineering tool that it's like another nice to have, but ultimately it boils down to engineering shipping faster software, engineering solving problems much faster. So it's a huge benefit for the organization, and it needs to be well communicated towards the leadership team and towards the decision makers in the company, so it will be transparent for them.
Awesome. And it looks like we have time for one more. And I'm curious, Ilya, your perspective here, because we talk about it quite a bit. And I talked about modern app dev, and you can pick serverless versus containers. When you're evaluating net new features, or you're looking at your overall application portfolio, how do you choose between Fargate or Lambda for your various different use cases or workloads?
Thank you, Carmen. That's actually a great question. Actually, we start with trying to figure out how long the specific workload is going to run. And if it's short enough, then it basically qualifies to run a serverless, because serverless has a max capacity of 15 minutes. If those are longer workloads and they need to save a state between them, or we would like to have some extra concurrency in them, then we'll go for Fargate. And every other longer workloads would also qualify for that.
Yeah, I've seen multiple dimensions on that one, and I like how you kind of attacked it in the short-lived. I mean, in all honesty, I've seen both use cases where people do fire up very short-lived Fargate workloads, but using that as the entry point for essentially your decision criteria is a really good one. So we only have 30 seconds. I'd love to actually talk about that one more, but unfortunately I can't. What I want to say in terms of next steps, if you want to learn more about containers, we have a plethora of information out there. Start with the containers page. The same thing with serverless. If you want to learn more about Epsagon, you have the link to their site right there. And again, thank you so much, Ilya. Thank you so much, Ran, Epsagon, Vonage for allowing the guys to present today. And to the folks on the call, I appreciate your time. And again, you will receive an email 2 to 3 days from now with a link to all of these slides on SlideShare. And in addition, you'll receive a recording to today's webinar. And I just want to say again, thank you very much for attending. If you have any questions, feel free to please reach out. And thanks again to the team.
Thank you very much, everyone.